Everyone. We're here with this is a new series of the Fall Academy called Machine Learning, and this is the introduction. And I'm here with a guest. Please introduce yourself.
Hello, everyone. My name is Abrar Qazi, and I'm a very close friend to Abdulaziz.
That's very nice to hear. So let's start. So machine learning can be basically broken down into these five categories. So basically, you have supervised learning, unsupervised learning, ensemble methods, deep learning, generative models. Yeah, I've just read from the thing. So in supervised learning, so what you basically have, you have the training data already. So for example, you have you have a set of data, and you have, let's say you have white training examples with certain labels, and you have black examples here. So in this set of examples, you've already had a prior sample, a prior distribution where you've labeled all your data points. For example, let's say a certain label, let's say me having hair on my jacket, white hair on my jacket with uh, with a certain smell. Those two features correspond to me having some form of a pet, and you've already have these sets of features corresponding with someone who has either a pet or not pet, and so you've already had the data beforehand, and the idea is to create a model that can distinguish that can correlate set features with the labels, corresponding labels. So that's basically supervised learning. You already have the labels associated with your training data or your features. And in unsupervised learning, you have these sets of points, but they're all, let's say, black, right? So you can't distinguish between them. But from the map that I've drawn here, there's a physical disparity. Basically, you can physically isolate the set of points because you can isolate them into distinct clusters. So you can use set algorithms like clustering, k-means, and such not to distinguish sets of data even without knowing their prior labels or you know or assuming the distribution of the set labels. And ensemble methods is a very powerful tool in which you can combine these models that you create, and you could even create these an ensemble of weak classifiers. And if you combine them in a certain way, they'll form a very strong classifier. And throughout this course, we'll learn about this. And deep learning. What is machine learning without deep learning? So neural networks is an essential core feature of machine learning, and it's used today in order to classify uh, like if you have a car, this is a horrible drawing, but yeah, just if you have a car and you want, basically deep learning forms the vision of the car. So the car can see cars in front of it, its associated distances. It can it's a way for machines to be able to see basically. And deep learning methods is very key when you have a spatial when you have when the when because in a pixel, the pixel itself is not enough to classify the feature. For example, let's say a pixel can be classified as red, green, or blue. Those three set features are not enough. So you need the space around that pixel in order to be able to correlate what that image is. And deep learning is a strong way in which, if there's a spatial locality, in ways in which you can use these methods in order uh, to be able to get some information from these images. And generative models is it's also pretty cool, and it's a way in which you can form models without also knowing the prior distribution. And we'll learn about this more as we move on in this course. Uh, so a formal definition of machine learning is defined by Mitchell in 1997, and I'll write down the formal definition. A, a machine learning basically is if you have a computer program A, and this is the computer program. Uh, yep, you have a computer program A. Uh, is learning from some experience E, which in which case is a supervised learning algorithm, and is learning from some experience E. So this is the experience. Uh, and from this experience, it's learning from some experience with respect to some task. So with some associated task. So that task is whether to class. Let's say in the first example I gave you, with having white hair on your jacket. Those are the task is classifying whether the person has a pet or not pet. So that is a task, and the experience is you having that prior distribution or the prior sample uh, that you have. And so, and of course, you need to be able to determine your performance measure. So with respect to your task, you need to know how well you performed on your set on your set on your classifier. So you form a model from your experience, and you need a performance measure in order to see how well your model fit with the actual data. And this is P. So basically, machine learning could be could especially within the class of supervised learning. You have a computer program A with some experience E, with respect to some task that you have to solve, and you need a performance measure to validate your task. So this ends the video, and I hope you're enthusiastic enough to stick around for this course. I'll see you later. Fall Academy signing out. And Abrar, please, my guest, please say something.
Yo, like I'm very excited for this new series, and I hope you'll find benefit to it as I will.
Okay, cool. Thank you.